Blues birdhouse, I'm able to detect which bird comes to visit and post it to a web server.
Here I am testing the Seed Vision AI v2 from Seed Studio with my bird model that's been shrunk to be really tiny and pretty efficient. As you can see, for the most part, it gets the flamingo. There are occasionally some issues, as it's only about 90% accurate. But yeah. Here, this one, continue with some other birds. This bird is the index 1 bird, so it oddly is saying bird here, but it's just something to do with their UI, as it's not really made to display 40 birds. Following that, I have this ruby-throated hummingbird here, and it's pretty accurate. You can see, able to move it about and it's still indicating it correctly. These are test images I did not train on. This one's saying nothing, but it's actually the 0 index bird. It's another of the strangeness of the UI when it's handling the labeling like this. And it did the same thing for the first bird index, as you remember. This bird is a duck. It's the 37 index, the wooden duck, because they're alphabetical. And what is this? I guess a snowy egret. And these again are ones I did not train on. And then I also shrunk the model significantly from the initial size, and this is the eastern bluebird. So this is a demonstration of it working with the Seed Vision AI v2 and my shrinking model stuff working.
So yeah, I just want to talk quickly about the model. I have it here in Edge Impulse. I didn't actually use Edge Impulse for any of the training or whatnot because I didn't need it. But I wanted to test using it because it makes it very easy to use individual images here. You can see the processing time on the model is 11 milliseconds for inferencing, a RAM usage of about 484 kilobytes, and a flash usage of about 154 kilobytes. And it's really small there because I used my shrinking techniques. Anyhow, this one here I had preloaded was the snowy egret, but let me try a couple different other ones just while I'm here so you can see them. And one thing to keep in mind is the different birds are only about 90% accurate because I had converted my EfficientNet v4 over to an EfficientNetLite, so I lost some accuracy in the process of doing such. And if I had started with EfficientNetLite, I think I would have done a little bit better than 90%. But it is what it is. I couldn't get EfficientNet v4 even in the shrunken state onto the seed hardware because I guess some instruction wasn't handled there. Some of the birds do a little bit better than others. One thing to keep in mind is birds are generally hard to do machine learning on because of the different variations of them, at least at this small of a size and small of a model. So being able to get it to this point has been pretty significant, I think, in terms of proving that it works in this sense. But yeah, I'll just do a couple more and then I'll call it. Let's see, American bittern. Let's try, how about this one with this guy sticking his head out? Yeah. Sorry, let me go back down. I'm kind of rushing. Here. And I'll try a flamingo. Let's try this one with his arms wide out. That's probably a little more difficult. Oh no, I got it. Yeah. And finally, let's do one more. How about the red-headed woodpecker? Sounds interesting. I haven't tested this one previously, so we'll see if it gets it. Yeah. Okay, great. So yeah, in general, it does a really good job on the test set here that I didn't train on or validate against. So it's pretty generalized, the model, and did a pretty good job. It fits well on the machine, and because it's so small, it processes at an incredibly fast speed. So I don't have any slowness from the FPS. So here I am in my notebook, and as you can see here, I have my TF-Lite model already present. It was created recently, and now I'm going to run it through the individual tests. And this was my data set that I did not train on or validate against. Probably said that a couple times in the video, but regardless. And here I have it going through the different batches to get an end running average. And as you can see, it starts off, and it goes through them,
and on average it ends up having about almost 90% accuracy. I then installed the Ethos U Vela tool via pip and then ran it for the Ethos U5564 and outputted it. And it has some data here related to that. And I was able to then take this and store it on the Seed Vision Sensor V2. Here I have the classification report, and you can see the precision recall F1 score and support. And in this particular case, the American bittern didn't do very well, and I believe part of the reason for that is a lot of the photos have the bird surrounded by grass, so it creates a distracting background that it's learning against.
So now it's assembled here, and I've tested it out, and it works perfectly. And I'm using a PG7 cable gland there for the wire that connects to the tilt sensor. And then once that detects and this is the top side of the camera. I probably should have done it the opposite direction, but it doesn't matter either way. The wire can be moved around the tree to get to the bird feeder to have it detect on motion. And there aren't going to be ducks or anything like that at the bird feeder, obviously. But I wanted to just keep that in here as they were Florida birds in my area. Here's my circuit setup. I'll go through each of the different pieces individually just to give an idea of how it's all set up. Let's start with the tilt sensor. So I took this cable that I had available to me and I crimped some new connectors onto it, DuPont ones, and I use this. It's for outdoor use, the cable, so it should hopefully work fine in my use case. And it's being powered via 3v3. The connector is here on this groove to DuPont wire connector, and I have that plugged into the serial voltage side on the 3v3 for my level up board. And so I'm just using the serial pins here, and I'm only actually using the digital pin. I'm not touching the analog output. In addition, I have my Grove Vision AI V2 connected to the 5-volt side here via my jumper there on my level up board. So it's getting 5 volts from that, or at least whatever's available to it on the 5-volt line. I'm currently powered via this V main here on the Blues note card to the 5-volt input pin, and I'm not using a diode in this case as I'm not planning on plugging in at the same time as USB. If I was going to plug it in at the same time I plugged in the USB here, I should put a diode in front, but I'm being smart about it, so I unplugged it first. I'll go into more detail in my article. And I have the ground connected to the common ground here for the Blues note card. I have the SDA and SCL connected directly to those pins so that they use the 3v3 versus the level up shift for my level shifter over there with the Grove one. So it's pretty simple. I'll use it for the sing diagram, I guess, to show it off. And what ends up happening is when this one shakes, it brings it down to ground for the pin, and then I'm able to detect that, take a picture here, and do inferencing on it. And if it ends up finding a bird, it then sends that over I2C to the Blues note card to report, which it reports every 5 minutes. I have it set to. And as you can see, I have a Flamingo open on my screen, which I was using to test. And it works rather well. It does send it out. And then I have the solar panel here, which I will be connecting to the input there for the Blues as well once it's in its case. So on the routing side, I've created this post image route. I'm going to jump into it. I've changed the authorization key here temporarily for this video, so I will be changing that back after, but for now it's just a simple one API key here for demonstration. So I have the route name, I have the additional authorization header here that's used for posting to the create endpoint as we talked about previously. And then I have it filtered to just the events.qo note file. And finally, on the data side, I have the JSONATA expression here with the bird, image, location, and country. On the Arduino side, you can see I have the includes here at the top for the SSCMA provided by Seed for the SenseCraft related logic using the Vision Sensor V2. In addition, I have the note card library being included here for the Blues. I have them here, and then I have some configuration options, the accuracy threshold for use with the inferencing, the pin that's being used to connect to the tilt pin, which in this case for me was the D7 pin, and a spot for me to insert the product UID. After that, I have this array here holding the bird names, and I'm not sure if there's a way to get it from SSCMA, because I did have to set the names there, but it wasn't returning them from what I could tell, so I just decided to go with this approach. And I have the array here with the bird names, and then in the setup logic, I take the tilt pin as an input. I initialize the Groove Vision AI v2 and the note card. I send the 5 minutes outbound and 60 minutes inbound for the blues. And I could have done continuous here instead, and then it would do it immediately. And I did that during my development. So this was added after the fact. And I might even want to, when I'm putting it outside, switch this to maybe 10 minutes instead of 5 minutes, just to reserve the battery a little bit more in case I get a couple images in a row. And I also was thinking maybe having it shut off at night so that it's not running at all at that point. Maybe put it in low power. But those are upgrades that can be saved for a different day. For the actual loop logic, I'm checking if the tilt pin reads 0. And if it does, if it's been brought to ground, then I invoke the AI logic via the seed vision sensor. And the third parameter here is for returning an image with it, which is useful in this project. I have the serial data here returning the debug information. In addition to that, I return then determine if classes were seen. And if they were seen, I check the accuracy threshold. If it's over a certain accuracy threshold, I then also have some more serial debug information, but I then send a note to the note card of the events.qo file, and on top of that I have the bird name as part of the body of what's being sent, and then the payload along with it, sending the base 64 image. And then it just submits that to the Blues note card, and from there it handles the routing in the Blues and goes from there. In this video, I want to quickly go over my Rust code and just describe how it all functions. So first, you can see here the README file, and I just have a quick little note here about generating an API key. I didn't use OAuth or any of the other forms of authentication here, just a simple API key in the authorization header to make it a fairly easy to get started and work with project without needing a user system. But let's continue. So first, there are the migrations, which you can get by running a CLI command to generate them, and it gives the timestamp there. And in this case, I'm just creating a bird's model, having the bird name here, an image of it in the base 64 form set and stored in the DB, and then the country and location. And these come from the Blues note card API. And then the created date that it gets posted to it. In addition, I've created a couple indexes to search by the ID, the bird name, if I want to order by that or whatnot, and the created at date. Go into the controller here. Now, one thing I noticed when I was going through publishing this is I probably should have moved the SQL code to the model. At the time I had first started with the controller, I didn't have the models directory yet. Not a good excuse, but maybe for a future refactor. But let's continue here. I have the bird upload parameters using Surday's deserialized trait. And that is used by the create method here, as you can see, expecting JSON with it. And it turns into the payload variable here, which allows me to then pass it into the query to store it in the DB. On the index side, I use this template here, which is, I believe, a Jinja it's called, or I might be butchering the name there, but it's a template that allows you to very easily create HTML from the text, or the variables rather, that you pass in. And there's Ascama, I believe the name is, crate that handles that for you. But on the index one, I am taking in the, on the index page, just doing a query against the DB ordered by the created at date, which I have that index for, that returns, and I'm doing it descending, yes, good, so that it's in the opposite order from the latest ones to the earliest ones. And I'm just returning the ID, the image, the bird, the country, location, created at, and I'm using it this way such that it can fill this bird model, which I'll jump to it right now. You can see here has these variables, or parameters, struct, whatever. Yes, in addition to that, after it gets that, it uses the template. It does an into iter here to create an iterator rather, and then it maps that to the bird context form for the struct, the bird context struct.
and it collects on that. And the logic that converts the bird to the bird context can be found again in the model here with the from trait. So from bird to bird context, and it just sets those variables. And I'm doing a little formatting here to set the location and country, and then the created that in a nice way at the bottom for some text for the date there. And if I did it otherwise, I'm not really sure how to do that in the other templating system. So this is helpful for me. And that's the gist of the controller there. In terms of the middleware, I have logic that checks the API key off of the state. So this is stored in a secret value, which I'll get to in a moment. But it gets that, it takes the header, if one exists, if it's some, it has a value there, and it will compare it against the stored value, the one that was presented, and if it is, it runs the logic, otherwise it returns this unauthorized error. And this only is run on the post verb there for the birds model. The model here, I already went into pretty much everything here, so I'll skip it. But to get to the routing, just to jump to that point, we have the get index route, we have the create birds route, and in this one I'm using middleware on the layer to do that authorization check, and it will return unauthorized again if it doesn't have it. For the DB one, I just have a simple wrapper here over the migrations. I was thinking I would use this for other purposes in the future perhaps, so I wanted to get started with this way of encapsulating it. Not necessary though if you want to just run this directly. In the main method here, you can see the shuttle Axum code with its runtime, and it's passing in the PG pool here from the shared DB crate logic. And then I have my secrets being returned in here. That is from my secrets.toml file. And in this case, I have the API key set in the secrets file. So when it fetches that, it's able to pass it into the routing and into the app state as needed to compare it. I suppose I could have just put the API key in and not passed it through the app state if I really don't need it on an individual controller level. So that's just a refactor that I could do. I have my template here, the birds.html one, that simply has some associated coloring and CSS here, and it just loops over the birds and posts the name as the alt text for the image here, base64 image, has the name, the date, and location, and just goes through them all like that. And that's pretty much the gist of this. There's not too much more to the Rust app. It didn't take me that long to put together, and it works pretty well. And here's my website for the bird sightings, and as you can see, they are listed in descending order based on date. You can see these ones that were upside down when I initially had not realized my enclosure had the camera upside down compared to how I was thinking. So I actually took the picture, and luckily it realized it was a wood duck. But from that point forward, I was knowledgeable about the correct orientation. So the additional pictures are in that way. The ones below this were ones I took prior when I was holding the device in my hands before it was in the enclosure. But as you can see, it does a pretty good job identifying the different birds, and I was able to get it to recognize them at different locations and not have a problem there, as you can see from my other video. And that's pretty much it. I hope you enjoyed the video. I'm hoping to create additional content in the future, so definitely like and subscribe to the video if you can. Thank you very much.